Like no religion there whatsoever. They're like a god.
All right, guys. So today's review day. Obviously, this test is on Wednesday. My God, finals coming up real fast too, man. The end of the semester. It's coming. What's that?
Is that going to take all 2 hours?
Is the final going to take all 2 hours? It totally depends on you.
Make it short.
The most it could take is 2 hours. So, there. That's the best answer I can give. So the first thing we'll do real quick is to do the formulas. So you guys can have all those in the formula sheet as always. Double check of the book to make sure you didn't just read my chicken scratching correctly. Yes?
Is the final going to be cumulative, or is it going to be just like from here on out?
Final will be cumulative. So the final will have stuff. I normally don't go all the way back to just pure definitions, but it'll have stuff all the way back to chapter 2.
You better have an L every day.
Anything else about general stuff? Yeah.
Will we get a practice like final?
Yeah, practice final. Yep. And they have we'll have a review in class, but they have another review, at least one, that they're doing through the Math Study Center workshop kind of thing. So I'll let you know as soon as they find a room and a time for that.
Would that be like a 2 hour class, or 2 hours, an hour?
Nowadays they're doing an hour. When I was in charge, it was an hour and a half. But I don't know what that means. So the formulas. This test is going back to chapter 7, starting at 7, going up through 9. You right, Gene?
Yeah.
Yeah. So it has stuff like this here. Get a better pen. There. This little dude here. Yes, sir.
You are going to be putting the formulas out the day of the test?
Right now, we're all making our formula sheet, so no formulas will go up on the board. You can bring all your formula sheets with you. Make sure they're not the ones you lost points on, if you did. So those are the three main things. Of course, what do these things do?
The interval.
Confidence interval, I love it. Right. And then I've got a couple formulas that are called the feasibility formulas to see how feasible a study might be.
Z or T squared.
Yeah, so I really just write one formula here. But the T-score, I desperately hope some of you guys understand. T and Z, who cares what the hell you call it? They both are the same idea. They both represent a distance away from the middle. T-scores are just more conservative. That's why I mix up T and Z star on the tests, because I don't even see them as different things. I don't care. So we had one where it's T squared, S squared over E squared. If you want to write that down, feel free. It's the same exact thing, though. Same exact formula. And then the other N, of course, is for the P stuff. Cool. And what do you do if you don't know P hat and Q hat?
0.25.
Yeah. You assume they're both 0.5, so the product would be 0.25. So in the book, you see a 0.25 here. They got it from assuming it was 50-50. Mathematically, it makes N the biggest it could possibly be in that situation. So mathematically, it makes sense. You're being the most conservative you can be because there's stuff you don't know. It seems to be a common thread for statistics, right? The more stuff you don't know, the more conservative you are everywhere. Yeah.
So we're allowed to use that 0.25 formula. We're allowed to write that on our formula sheet.
No. You have to know that. It's the same. It's this formula. But if you put a 0.5 and a 0.5 in, you get 0.25 there, right? The product. Cool. Okay. So that's chapter 7. Yes, sir.
What do you call these formulas? The same thing?
I wish I knew. Oh, these I call them feasibility formulas, but they're sample size formulas. Since it's solved for n, it's the question would have to say what? What would the question have to be to know to use this? How many? How large of a sample? How many people we have to talk to? That tells you want to use this formula. You want to know what n is. You don't know what n is. You can't use something that has to have n in it. You want to use something that solves for n. Kind of makes sense. Yes, sir.
Confidence interval is how well you can do that procedure?
No, it isn't.
Okay.
I'm not sure exactly how to answer that question, but the confidence interval doesn't tell you how well you conducted a survey. Is that sort of like what you're saying?
Yeah.
I mean, the larger of a sample you took, the less error there would be here, right? So in a way, that's sort of right. If you just look at how well you did based on how many people you talked to. But we know in statistics, how well you sample has a lot more to do than just with how many people you talk to. It has to do with, did you take a random sampling? Right? Yes?
For the Z-score you had, can you also put a T where the Z is, or no?
What do you guys think?
No.
What is it with T's and NPQs?
They don't have it.
They don't go together. I like it.
Okay,
So with
just making
NPQ
sure,
problem,
because
it's either normal
Always Z.
and you use Z, or it's not normal and you wait till stats 2.
Just making sure, because I think I remember that. I was just making sure.
They do, if anybody's curious, they keep mentioning all this. There are a couple places in the book, and one example I saw, somebody came in and we looked it up real quick in the book, and they do talk about something called the bootstrap method, which just sounds really interesting. But bootstrapping is used a lot for covering your ass when you don't have a large enough sample, when you have certain conditions that aren't met. If you look up bootstrapping in the index, there's one little quick blurb about it, if you're at all curious. And the rest of you are like, no, dude, I'm just going to try to get ready for your test. Thank you very much. So I understand that too. So let me see. So then chapter 8. The only real thing it introduced that's new formula-wise is, for example,
C-star?
this one here. I mean, that was new. The Z-score formula, we use Z-star for a mean. It's the same old formula we've used forever. Right? So if you want to write that down again, you can. You can have Z-star x bar minus mu over sigma x bar. Sigma x bar equals sigma over square root of n. You could have Sx bar. What's Sx bar?
The standard deviation of it.
It's crazy.
The
S over
standard-
square root of n. Right? You guys got it with me? Yes, sir.
So, we used that first formula when we were dealing with the MPQ problem, the p hat minus p.
Yeah, this formula would be, could somebody give me a situation when you would use this formula? What chapter is this from?
8.
What's 8 all about?
Hypothesis testing.
Okay, can somebody give me a situation where you might use this kind of formula? When you have a,
Out of how many, like, proportion? It's like, if some number is like out of how many numbers?
when you have a claim about the percentage or proportion. I'll take a proportion. That's right. Same definition for proportion as percent. That wasn't too bad, right? Wasn't too painful, was it? It was very painful actually for my side. But I mean, this is obviously if you're going to have a test about a mean, but this is also, we used this before without tests. I mean, that's just the same old Z-score formula from before. So really, these Z-scores are defined on their own. What do these Z-scores tell you? Oh shit! I'm gonna have that question on here again. And if anybody says anything about area, I'm gonna go insane. All right, just to be really evil for a second. But what does a Z-score tell you?
If it's in the rejection region,
How much data it has?
How far away from the mean it is in standard deviations, or how many standard deviations away from the mean to the data point. I love that. That's the only thing a Z-score by itself can tell you. If you say something about area, number one, I didn't say anything about normality. And number two, you have to use a chart to get the area. You can't get that from the z-score. Z-scores always tell you how far away. And why does it make sense for a hypothesis test to use it? Because for a sample to show evidence, it's got to be really freaking far away from something else. I think it's here. Well, actually, it was way over there. Oh, shit, it looks like I'm wrong. That's basically a hypothesis test really condensed. I think it's here. It's over there. Well, I'm wrong, shit. That's hypothesis test. Right? And we build it up into 5 steps. Yeah.
So it's how much to data point?
So a z-score tells you how many standard deviations from the mean to the data point. And you can be even more specific. If I give you a negative z-score, you can say it's that many standard deviations below the mean, right? But as long as you say away from the means, that's what I want to see. Because that's what a z-score by itself tells you. We can use a z-score in a lot of freaking different ways. But do I need to have a normal distribution to calculate a z-score? Hell no. Do I need to have a normal distribution to use a z-score in a lot of situations? Hell yes. But to get a z-score, I don't need a normal. I can get a z-score for anything. If I can count the mean standard deviation, I can get a z-score, no problem. Or percentages. Okay, how are we doing? Semi-decent. Okay. Let me think. What else have I? Oh, and of course from chapter, I think that's basically chapter 8. Yes, and then chapter 9's got these big things here. This guy. Okay. Now there was a little more at the end here, but normally that goes away, and in fact for all of the ones we had to do, they pretty much go away. Okay. And those are bigger because it needs more room to put 2 samples worth of information in there, right? These can be smaller, they only got one sample's worth of information to put in there. Cool. So anything else that you think should go up there? You can use all your old formula sheets, I don't care. Just whatever you use, you got to turn in. Did you have a...
So that's chapter 9, chapter 9, right? Dealing with 2 samples.
That's right.
But chapter 9.4, it's like, it just gives us a list.
Chapter 9.4 actually kind of goes back to chapter 8 in a way, because the first thing you do in chapter 9.4 is you subtract the 2 lists they gave you. So I didn't put a problem like that on the practice test, because the first thing you do is subtract those lists, and then you have a single list. You find the mean, you find the standard deviation, and you use this kind of thing. Yeah.
Is there a formula for getting the P-bar and the T-bar?
Oh yeah. Thank you. That's a perfect example of what you should be able to have up there. So P hat in general is, so P hat 1 is x1 over n1. All right, so you know what P hat 2 is. So P bar is x1 plus x2 over n1 plus n2. But a lot of times, what's more important than the formula is the idea, because the formula makes something look worse than it really is. P bar is just take everybody at once. Don't split people up into groups. Just put them all together at once. So many people want to see an example of a P bar, figuring out P bar just by itself.
Let's do it.
P bar. How many of you guys are left-handed? Not enough to do this. Okay, I understand. Thanks, Paul. Sorry.
I can.
So everybody got what they need from up here? No. Okay. Yeah.
So T star is the same.
Well, here you might have a T star.
Yeah.
The only difference would be there would be S1 and S2.
Yep, the steps
Yeah.
at the beginning.
But you could use it with the T?
Yes, definitely.
Yep,
Definitely. Now, I want to try to explain this. Some of you guys maybe get this. There's a huge deal about when to use Z-scores, when to use T-scores. They are obviously different things. You use a different chart. Depends on the sample size for the T-score, all this stuff. But they both measure, using star, they both measure the same thing. That's why here, I don't care if we call it Z or T star, who cares? You calculate how far away, according to the situation, how far away are these things from each other. I don't care if you call it Z star or T star, it measures the distance. That's what it does. So that's why I look at Z and T star as one. I don't care. Now, when you set up your critical region, you want to look at the right damn chart. You don't want to just say, well, Jeff, you said Z and T are basically the same thing. No, you got to use the right chart to set up what far enough away is. But then when you calculate a distance, who cares what you call it? So that's why sometimes, like on the practice test, I put a Z star when really you should be a T star, but I don't care. I could have just said calculate the appropriate distance, and that would have really freaked people out. All right? So on the test, I'll probably just change it all to say Z or T star, depending. We'll see who freaks out about that. So anything else? Any other suggestions on formulas or anything? All right, let's do this. Let's do it real quick. Has everybody got what they need here?
Yeah.
Let's do a real quick example of Keybar. So if I had 38 men, and 11 of them said that they go to the doctor regularly, and I had 47 women, and 40 of them said they go to the doctor regularly. This is probably somewhat close to real. Guys, we just don't like going to the hospital. P hat 1 and P hat 2, pretty straightforward, right? How do you calculate P hat 1?
Divide 11 divided by 30.
Yeah, 11 divided by 38. So what is 11 divided by 38? 0.29? 0.29.
Oh, more.
289. 0.289.
That's right.
289.
289?
Yeah. I just typed 2.
That's all right. Not really. So we gotta be careful. Take that bad boy out at least 3 places.
Okay.
P hat 2.
0.85.
Yeah, 40 out of 47.
851.
851. So if that was part of a test I was doing, I almost don't have to do the test. I mean, 85% versus 29%. Wow, that's really, those made up numbers really tell us something. All right. P-bar, what's P-bar? How do you get P-bar?
Adding all of them
Add
together.
11 plus.
Put everybody back together. There's one group of people. So I've got a total of 38 plus 47 people. And I got a total of 11 plus 40 that go to the doctor regularly. All right.
0.6.
So tell me this, before you everybody does this. It's sort of an average of these two, but it's not an average because there's more of these. So what number is it going to be closer to? 0.29 or 0.85? 0.85, because that's the one that's got more people. It makes sense. So it's going to be somewhat in the middle, just a little bit closer to 0.85. So what do you guys get?
0.6.
0.6?
Yep.
Cool. So that's definitely a little bit closer to 85, right? 60's 25 away from there, but it's 31 away from there. Okay. How are we doing? Okay. And again, I think maybe most of you guys understand when I say chapter 8, chapter 9 are like the same exact problem over and over. I don't know if you've noticed this. It's the same 5 steps. You have different Z-score formulas, but that step is how far away did you get? That's what it is. You use the right formula, but you're getting the same damn thing. How far away did you get? Was it far enough? And then you know if you failed or if you didn't fail. It's the same exact idea. Okay. All right, so now I'm going to leave it open to whatever you guys want to look at. Anything from the homework, from the practice test? Yeah.
So, are you gonna give us like what the claim, like when, like what we supposed, like what the claim is?
What the claim? Yeah, I've got to tell you what the claim is.
We can't like guess what the claim is based on.
No. Yeah, you can't guess. Yeah. We're sort of like stats consultants. And somebody gives us their problem, right? A stats consultant will come in. I'm not going to make a claim about your company because I don't know your company. I just want to work with the data. You made a claim about your company. My claim is my company will make $1 billion. Well, I can tell you right now. Right, so I give you your claim, give me that. So I can't make my own claim up. I have to base myself on what you say is going to happen. Juan, you good?
Yeah. Can we go over the practice test?
We can. So that starts where? The last two?
The last
Few. I think few officially means 3, but I don't know. So starting at number 3?
3,
4.
4?
3.
Yeah, number 3.
All right, let's do 3.
Why would just do the entire thing?
I finished one.
It's less time. It's like it's less than this. We're talking about less than this. So that's what we write for the claim. But the one.
All right.
It's not useful.
Do you have an extra one at all?
Thank you. I'm so excited. Aren't you excited? Really?
All right, guys, number 3. Pain reliever. Best pain relief is when that final's over, but I can't do that for you.
You can call it sit there.
So, what's the claim being made? I'm not necessarily going to bold it on the actual test, but I thought I'd try to help you out. Practice. So the actual claim being made is what?
Less time.
All right. So now make that more mathematical statement.
Mu is less than 16.1.
11. What number would you never see show up in the claim or the hypotheses? The 13.7. That's the sample mean. That's what I use in step 4. I don't know any sample yet at this stage. I just know a claim that I want to make, or that's been made. That's going to be which one of these?
H1.
H1. And then HO would be
Greater than or equal
Greater.
to.
Has everybody tried this problem out yet?
Mm-hmm. One tail.
Several of you? Okay. All right.
One tail.
So one tail.
T-scores, because S is given. The sample center.
Yeah, so it's definitely going to be T-scores for 2 reasons.
And
the sigma somehow.
Yeah, N is 41 greater than 30. Check. Central limit theorem. So that tells me I could do something. I'm not in stats 2 yet.
and it's S stands sample center deviation.
Yeah, S known, not sigma, so that's why it's going to be a T-score. That's a freaky little sigma. There you go. Yes, sir.
So, like if S is, if they say standard deviation but they don't say S, then we would have to know either if it's a population or.
Yeah, I've got to be really obvious if it's a population.
If it's
But
a
if I say, like, I took a sample of 80 people, and the mean was 12 and the standard deviation was 11, obviously I'm implying the standard deviation came from that sample I took. Otherwise, I've got to say all people have the standard deviation, or the population standard deviation is blah.
Yeah.
I've got to be very specific. Know that I'm not going to use the symbol like I did in number 3. I'm not going to say S. That's kind of a giveaway. Right? Part C, what tells me how to set up the rejection region? What all do I have that I need here to get the rejection region?
Alpha.
I need N. N is 41, so degrees of freedom is
40.
40. Alpha,
It's 0.05.
05. I know it's a one tail, so I'm going to look at 0.05 all in one tail.
It's the left side.
Left.
Left side because
Good.
it's last
So it's
down.
going to be less than, so I know it's going to be down here. Question?
1.684.
1.684. So 0.05, one tail is going to be the second to the last column, right? And then you stop at 40. 1.684, good, and it's going to be
Negative.
beautiful. Cool. And then in words, it's going to be
If T star is less than 1.684, we reject HO, support H1.
cool. Yeah,
Do we always support H1 no matter what? Like,
or fail to support it. Yeah. So you only use the rejection language with the HO. You only use the support language with the H1. And the reason that is, I can never prove that something's equal to something else using a sample. I can't. Right? And I can never outright reject that the mean is bigger or smaller than something because it might just have been that one sample I took wasn't good enough. So I can either support or fail to support the H1, reject or fail to reject the HO. And it's not just stats people going, why does English get to have all the grammar problems? It's happening. No, it's not just that. We don't want our own semantic problems. It's just the best way to describe what's going on. So if I get in the rejection region, I reject the null. Cool. So that set up how far enough away is good enough. And then part D is going to be how far away do we get. So you guys take a minute here if you haven't done this yet. Try to figure out what the T star is.
Negative 2.18 T star.
Yeah, so your new standard deviation, what do you guys get for that?
1.1, yeah.
And then the T star will be your data. Your data always comes first. Minus the mean, which we accept to be this dude, divided by that new standard deviation. Just to see how far apart they are. How far apart is what I found from what I thought I should find. If they are very far apart, that's evidence that that thing is in the wrong place.
Negative 2.18.
1.8?
Yeah, okay.
183? Okay. And so what does that mean?
It's in the rejection region.
It's in the rejection region, I like it. First thing we can see visually, it's definitely down in there.
So we supported the claim.
So this was the supposed middle, and we got so far away from it that we can reject the one that says it equals that. It's got to be wrong. It can't be equal to 16.1. It can't be greater than 16.1. It's evidence that it's less than. So I can reject the null. Support H1. Which one is my claim?
H1.
So then I'm going to use this language in my conclusion. Right? I just circle the one that deals with my claim.
So if we were to find a p-value, do we have to look up like negative 2 point? Like we have to like with the p-value, we have to find the area. Like
Yeah, remember for a t-score, you can only give a range, and it's a little bit of a strange process to go through. So I might make a bonus question on the test related to that. But expect a p-value problem, a p-value question with a z-score problem. If you get z-star, I can definitely ask you a p-value question on that.
it doesn't work with t-star.
It does. It's just that the chart we use is now nowhere near as precise. So we just get a range of values. Yeah. So how do I word this thing? Here, you guys try to word this thing. And I'm going to pass the answer key out. You can see if I got it right.
Whether it's a 1 to a 2 test, is a 2 test usually when it's only on equal side, and 1 is when it's less than or equal side? Or, I mean, that's not clear.
Exactly. So, two-tailed test sometimes it's difficult to tell because you can't find a word that tells you if it's lower or increased or something. And that normally tells you, oh, it's a two-tailed test because the word would be is. It's so easy for us to look that over. We think it is 14, and we're like, okay, is it less than, greater than? I can't see. No, it is. That's equal to. So the other one must be not equal to. Yep.
Alright. Do you remember p-value, like the area under the, like our p-value is like we're trying to find the area of our t or z star. If for extra credit, maybe I can help you. Because I kind of don't know how to do it.
I should have made this problem about that product. Apply directly to the forehead. You just remember that? The apply directly to the forehead. That would have just been my own personal joke. That's all right. I have a lot of those. So take a look. Be really careful because on the test I'm going to do the same thing I did here. I'm going to have one problem that has A through E. And then the next one's going to say, make sure to use all the 5 steps. And a lot of people skip step, just A, B, C. You do the exact same steps. Do all 5. You with me? Don't skip something accidentally. I think 4E, I was getting tired.
I thought we found sufficient evidence.
Where are we at? No, not on that one. Okay, that's number 5.
Oh.
Yeah.
Oh.
So I say this every time, but don't fall into the trap of just agreeing with what's on the answer key, right? If you haven't tried the practice test out, don't even look at this thing, really. If you're not going to do the practice test, don't look at this thing at all. It's not going to help you. It's going to make you have false confidence.
Right at the beginning, when
How is it less than me, which is less than me? I don't get it. It doesn't give us me one and
Isn't crazy. Yeah.
Do they say ID and then on the next question they say?
No. That's so wrong.
Where are you looking? Number the problem we just
They
did.
have to memorize.
Oh yeah. Why did I do that? So on 1A,
Well, they only give us one thing, it's not me one.
the number is 32, so it should be 32 on the bottom. Square root of 32, yeah.
That's what the conclusion is on number 3.
We're doing number 3 and number 4.
Oh, okay.
You're looking at that.
Hey,
Do you have an extra?
all the blank ones?
Oh,
Thank
Sure.
you.
Yeah.
so like the conclusion would be like you have found sufficient evidence for the claim that the mean decreased from 16.1 or time relief, the average time relief.
Good. Yeah. Either way of those. Either one of those. Yeah. It's got to relate back to the physical, what's going on.
So like, how many tests are you gonna have each of the steps written out for? So
Yeah. It's going to be just like this, though. I'm going to have one that has all steps written out,
Oh, and then
maybe I have one more that doesn't.
okay.
So you just have to go back and use all the steps.
And then you said that it's not you're not gonna have like the S.
Right computer.
No. So I would say like the new drug is given 41 steps, and we find a mean of this
I think it's
with a standard deviation of that.
because if I know
So you just have to realize it came from a sample, so it's S, not sigma.
And that's like I can do.
If I meant sigma, I'd have to say all students have a standard deviation of this, or population standard deviation of this. Yeah.
Want to get paid on? Yeah, but I've never tried to.
So point estimate is just the X bar or the P hat. These are point estimates.
Want me to do it?
X bar is point estimate.
Yeah. So it's just like in algebra, we have an interval of numbers, but then one of them would be like a point. We actually call a point to the piece, but who cares? That would be a point in the middle of an interval. That's my point estimate. If I had to guess, I would say it,
So we can leave.
because it actually came from my sample. It's my best guess. Yeah.
You're gonna stay.
I just want to ask you something. So for number 3 underneath, so this part, how would it be different?
Oh, did I not write down?
I want
Shoot.
to take my own part.
I just want to make sure that what I wrote is right. So I wrote that if you have a rejection region of 0.01, you would have a T-score that, which would mean you would fail to reject no rejection.
I love it.
Yeah,
Is that right?
Good.
Okay. Because it would be.
but I do it by myself.
So real quick on 3E,
Schools and
I left that second part off. So what would change if I changed alpha? What's the main thing that would change?
The rejection rate.
Yeah, the rejection region. Anybody can look that up for me if it's 0.01 instead of 0.05. You really should go look next to this.
Negative 2.423.
So now it would be negative 2,423. So this is the second part of 3E.
So it would be
This would be negative 2.4 something.
2, 3.
Thank you. Yes, strong memory. Just doesn't last very long. And we got negative 218. So now if this is my rejection region back here, and negative 218 is not in there. So in that case, we would have
Supported the rejection. No, wait.
Reject.
we would have failed
Failed to reject.
to reject. We didn't make it in there, so we failed. I love it. Right? We would have failed to support. In this case, we had them worded the same. We would have failed to support it. It would not have been strong enough evidence at that more difficult level of significance. This is why we call it a level of significance. If I make it smaller and I still pass it, that means that my findings are more significant. Yeah,
So it's still a one-tail test, though.
totally. Nothing else changed.
Only that
The
alpha.
only thing that changed was the alpha. So the only thing that would change would be that.
Okay.
But then we wouldn't make it in there.
2.423. Our T-score was negative 2.4.
Oh yeah. This becomes negative 2.43. So negative 2.18 is higher than negative 2.43.
Yeah, so
2.3. So
these,
it's not in the
how
rejection
would I
region, so we
figure
fail
out
to support
whether it's the two-tail or one-tail?
claim. We have no
Confidence intervals are always. So what a confidence interval always does, by definition, is it captures so much in the middle. So it always makes
Are you prepared for this?
two tails. Confidence intervals always.
Okay, so I was looking at this and I'm like, oh my god.
Because now
I'm
if you want 99% confidence,
Practicing.
that means that there's 1%
So hopefully I'll do well.
in two tails. Exactly. So you pretty much always look here.
to do well.
Okay.
If you just take 100 minus this, you can always look there for the rest that's
And
outside.
now, when it says population mean, am I just assuming that this is it's a huge number? So when I go look at the
Pissed off when you do
the teacher, would it be a T-chart
You complain
or a T-score? If it's the sample mean, so I'm assuming it's a T-score because it's a sample.
The N is probably going to come
At
out
least it's not a
large
higher
enough.
level statistic.
So
Like,
that's why, strictly speaking, we normally have this.
are you planning to transfer?
But if you want to be more conservative, like you used on the test, we use this.
Did you get in?
But most of the time, you actually just go ahead and use this because normally your N is going to be in the thousands.
So far, yeah.
That's amazing.
Whereas this was more like you could probably have.
So degrees of freedom. If I'm looking at the teacher, I would go
Yeah,
all the way down
if
to
they
the
don't give you
bottom.
any information about any sample taken, then you just want to know how large a sample you want, you use this formula here.
Graphs.
Because there's no way to know what T-score to put in there.
Oh, yeah.
It'd be like the
okay,
T-score
okay.
for degrees of freedom is 0.
So I use that to find my degrees of freedom.
What's your major?
You don't need degrees of freedom. All they're asking for here is the sample size you should need, right? And they tell you that the population standard deviation is this.
Like the last year.
So that tells me I'm going to use
Yeah, I'm
Zscores.
not
not-
using T-score.
yeah.
Oh, so
Okay, cool.
it's like
Thank
your
you.
second.
I think they said, no, they don't say it, do they? They don't say anywhere that it's normally distributed.
I only took one.
So that's their problem. They should
Yeah,
have
I'm
said
just
that.
freaking looking.
So that's what you're looking for. But it's the fact that I know the population standard deviation that tells me I don't need to use T-scores.
Okay.
Yeah.
Was that your first semester? Yeah.
I was asking
Oh,
about
so-
the conference interval.
So you're a freshman.
Basically.
Oh, I'm supposed to be a senior and I'm supposed to graduate
Mhm.
this year.
Oh, the
I didn't.
How old are you?
22.
I'm 19.
So if I had 30 people construct their own confidence intervals for each make their own 95% confidence interval, I would expect 5% of them to not have the real mean in it. So I'll make a confidence interval, and then you make a confidence interval, and then somebody else makes a confidence interval, and then the real mean is like, you know, where's a good place to put it? Here. So it's in this one and this one, but not this one. Does that make sense?
Yeah.
So 5% of the time,
Focus on mine still.
somebody's confidence interval will not catch the real mean.
I'll focus on
So I can live with that, right? That means only 5% of the time I'm going to be wrong. I can live with that, yeah. That's the real meaning of this. That's why we say we're 95% confident that our interval caught it. Because 5% of anybody making it won't. So I'm 95% sure that mine will. Beautiful. Exactly. So that's why we use that confidence.
They don't have tutor, like tutors.
This is the quiz. I don't understand why I'm using X-rays right now.
Oh yeah. So the standard deviation this year, where did it come from? Yeah, it came from that 51 parents I surveyed. So I didn't talk to